Alright gang, we made it. We're 5.9 day 3, dividing complex numbers. So the last lesson we looked at adding and subtracting and multiplying. So what we have left is dividing. So the different steps we take to divide are we multiply the top and the bottom by the conjugate of the bottom complex number. So remember that the conjugate of a plus bi is a minus bi. And this is why we're multiplying by the conjugate. Expressions in the simplest form can't have square roots in the denominator. Since the imaginary unit represents a square root, you can't have an I in the denominator. That's why we multiply by the conjugate. The next thing we do is distribute. Then we use that I squared equals -1, just kind of like we did in the last lesson. And then we simplify. So let's try this out. The first thing we're going to do is figure out what the complex conjugate of the denominator is. So we have a plus bi, and here we have a is equal to 0, and b is equal to 8. So now we want to write a minus bi. So what we really have is -8i. So we want to multiply the top and the bottom by -8i. Now we want to distribute. So 3 times -8i is -24i. And then we have 7 times -8i is -56i squared. And then we have 8i times -8i, which is -64i squared. The next thing we want to do is we want to see that we have I squares. And we know that I squared equals -1. So we're going to substitute that in. So we have -24i minus 56 times -1 over -64 times -1. So let's simplify now. We have -24i plus 56, all divided by 64. Now what we can do is we can simplify. We can see that each of these numbers is divisible by 8. So divide by 8 is -3, divided by 8 is 7, and divided by 8 is 8. So what our answer is -3i plus 7 over 8. And you can rewrite that if you would like as -3/8 I plus 7/8. Or you could also rewrite it as 7 over 8 minus 3 over 8i, if you choose. The last example we have here, we're going to go through those same steps. So we want to figure out what a plus bi is, and then find the conjugate for the bottom. So we have a is equal to 2, and b is equal to -4. So our complex conjugate is going to be 2 plus 4i. So we're going to multiply the top and the bottom by the conjugate, 2 plus 4i. And then our next step would be to distribute. So we're actually going to FOIL this one first. Outside, inside, last. First, outside, inside, last. So we have 5 times 2 is 10. Outside, 5 times 4i is 20i. Inside we have I times 2 is 2i. And then we have I times 4i, which is 4i squared. And then the denominator, we have 2 times 2 is 4. We have 2 times 4i, which is 8i. Then we have -4i times 2 is -8i. And then we have negative 4i times 4i is negative 16i squared. So let's clean it up because I see we have a couple of terms right here, right here, and right here, and right here that can be combined. So we have 10 plus 22i plus, and then I want us to remember that our I squared equals negative 1. So we have plus 4 times negative 1 over 4, and that's 0, minus 16 times negative 1. So we can simplify it even more. So we have negative 4 plus 10 is 6, so we have 6 plus 22i over, we have 4 plus 16 is 20. We can simplify this by dividing by 2. So 6 divided by 2 is 3, 22 divided by 2 is 11, and 20 divided by 2 is 10. So what we're really left with is 3 plus 11i over 10. So you can rewrite it like this, or you can break it apart and say 3 over 10 plus 11 over 10i. Either way. So go ahead and try the try problems at the bottom. Oh, and I'm supposed to give a shout out to Mason for hitting the freeze button the other day, so way to go. Thanks for not being lazy on me. Alright, so you try these two, write your summary, and good luck.